Okay, everyone, the final thing that we're going to be talking about in this section is how to apply what we've been learning graphically. So far, like for example, back here when we were solving these types of problems, so way back here, whoa, I went way too far back. Sorry, guys. Back here, when we were talking about the zero product property and all that, okay, what we did was I gave you a polynomial and you had to solve for x. Well, now we're going to talk about what this means on a graph and how you can actually use polynomials to help you solve things graphically, which is pretty awesome. I can already see that you guys are like super excited, which I'm already excited, so get pumped up. But anyways, again, we talked about that finding zeros, roots, x-intercepts, solutions. When you solve for x, all four of these words have the same meaning, and that's what you are solving for when you solve for x. Okay, so let's talk about what these things are on a graph. Okay, so probably one word that jumps out at you in this problem is x-intercepts. Okay, x-intercepts are where a graph will hit the x-axis, or where it smacks the x-axis. Okay, so like these 2 points right here is where this polynomial is hitting the x-axis. So since I told you guys that when you solve for x, what you're solving for are zeros, roots, solutions, or x-intercepts, guess what? When you solve for x on a polynomial, what you're actually solving for on a graph are the x-intercepts. So when we've been solving for x this whole time, you guys have secretly been 3, 0, 4, 0, negative 1, 0, negative 2, 0, negative 3, 0, negative 4, 0. Okay, so if we're thinking about these as points, which the y-coordinate is always the second point, what's your y-coordinate if all these points are like 1, 0, 2, 0, 3, 0, 4, 0, negative 1, 0? You guys getting the hint? Okay, when we're on the x-axis, your y value, which y is the same thing as f of x, okay, your y or f of x is 0. Okay, so that's why when we've been solving these polynomials, if you think back to here, okay. When you think back to here when we were solving, I told you that one side of your equation had to equal 0. Well, that's because typically on one side of your equation, usually there's like a y equals or an f of x equals. So we have made the y or f of x 0 so we could find the x-intercepts. Okay, so when we solve these polynomials, if you want to find the x-intercepts, you must set it equal to 0 because secretly the y or the f of x is getting replaced with the 0. So that was the importance of the equation being set equal to 0. So if you're solving these and you're like, Miss Long, why does this thing have to equal 0? Well, that's really why we've been setting these equations equal to 0. Okay, so when we are solving using a graph, what we're going to do is we're going to set our polynomial equal to 0 because y is always 0 on the x-axis. So just keep that in mind when we're solving. Okay, so we have 2 word problems that we're going to be solving where we're applying the concept of finding your x-intercepts. Okay, so let's get started on example 7, which if you want to copy down example 7 from here, you could like pause the video and copy it down. My handwriting's obviously not that great, so if you'd rather copy it from the pretty typewriting, I would pause your video and copy down example 7. Otherwise, you can look at my chicken scratch and copy that down. Okay, well, let's get started on example 7. Woo! Okay. I don't think I can zoom in anymore. Let's see. No, that's like way too zoomed in. Okay, sorry, guys. You'll just have to deal with the smaller picture. But anyway, so example 7, we have an art gallery that has walls that are sculpted with arches. So we have like a fancy art gallery. So the walls are kind of like these arches right here. They're sculpted with arches. So you like walk through the archway. And it can be represented by the function f of x equals negative x squared minus 4x plus 12. Now guys, in math word problems, usually if you see numbers or variables or equations, those are usually the most important parts of the word problem. So just keep that in mind. So this is probably going to be helpful later on. Okay, so these arches can be represented by the function f of x equals negative x squared minus 4x plus 12, where x and f of x are in feet. So the dimensions that we're going to get are in feet. And what they're asking for is what is the width of each arch at the floor. Okay, so we want to know how far apart are the arches when you're at the floor. So I kind of have this floor drawn right here, which the floor is going to represent like our x-axis. Like if we have a coordinate grid right here, the floor of the arch is going to be the x-axis. So this is representing the x-axis. We have the floor. Here's the pretty arch. And the problem is curious as to what is the width or how far apart are we in between these 2 points on the x-axis? Or how far apart are we from our x-intercepts? Okay, so in order for me to find the width of the arch, guess what I have to find? I have to find my x-intercepts, or my roots, or my zeros, or my solutions, which means I need to solve for x. So, be careful though, you guys. Don't forget when we're solving, they gave us f of x in the problem, which don't forget f of x is like the same thing as y. This could have been y equals negative x squared minus 4x plus 12. Okay, since we're figuring out points on the x-axis, if you remember, what is the y value always on the x-axis? Well, it's always 0. Okay, so in this problem, we're going to make f of x 0, which I already did right here. Okay, this is just stuff for the problem, so if you want to ignore that for now, you can. So I went ahead and made f of x 0 because I want to find x-intercepts, and y is always 0 on the x-axis, which remember, y and f of x are the same thing. So you could also say y is 0. Okay, so from here, guess what? It just turns into one of those problems that we're already used to solving. So from here, if you want to solve for x, like we're going to be solving one of the problems that we talked about earlier on. Like this is going to be very similar to one of these problems. So if you want to try to take it from here, I recommend you do so. But if you're like, Miss Long, it's been a while, I think I need a recap, well, that's fine. You can watch me. Or if you just want to watch me do it, why not? Okay, well, let's get started. So we have set this equal to 0 because y is always 0 on the x-axis. Okay, and what we have to do first is to factor the polynomial. What factoring technique do you always try first before you try any other techniques? Holy hot dog, you guys would try to factor out a GCF. Okay, and I'm just going to cover this up for now so we're not focusing on all that. Okay, I can see you guys looking at it. Stop looking at it. But anyway, so I need to try to factor out the GCF. Okay, which secretly, what's in front of my x squared is a 1, so it's negative 1x squared. So I have a 1, a 4, and a 12. What is the largest number that I'll divide into 1, 4, and 12? Well, that would be 1. Okay, so our GCF is technically 1, but if you guys remember, whenever we factor, we do not like the leading coefficient to be negative. Okay, usually things are just much harder to factor and much harder to reduce down and simplify if we leave the leading coefficient as negative 1. Now, it's not wrong technically to leave the leading coefficient as negative 1. Okay, but your life will be much more difficult if you do. So why don't we make our lives less difficult and deal with this negative 1? So, what must I also factor out to transform that negative 1 into a positive 1? Nice job, you guys. We do need to factor out a negative 1. So our GCF is going to be a negative 1. Okay, so I'm going to divide every single term by negative 1. I'm going to write what I get I'm going to write my GCF on the outside of my parenthesis. Our equation still equals 0. Okay, I'm going to write what's left over in my parenthesis. Okay, so negative 1 divided by negative 1 is a positive 1. And I don't have anything to combine to that x squared, so I'm just going to bring it on down. Okay, and you could put a positive 1 in front. It's kind of up to you. Okay, and then next, negative 4 divided by negative 1 is positive 4, so plus 4x. And then negative 12 divided by negative 1, positive 12 divided by negative 1 is negative 12. Okay, so after you factor out the GCF, do not forget you always must look inside your parenthesis and ask yourself, can I keep factoring what's left over? And guess what, you guys? I'm pretty sure we can. If you have 1, 2, 3 terms and your highest exponent is a 2 or a quadratic, what factoring technique can we use? You can use slide and divide. You guys are so smart. Okay, so we are going to use general factoring or slide and divide. So let's start identifying the A, B, and C. My A is going to be 1. My B is going to be a 4. And my C is going to be negative 12. Okay, so let's start solving. Okay, so I'm going to start by sliding and dividing. I'm going to slide A to C. Okay, so I want to find two numbers that will multiply to be AC and eventually add to be B. Okay, but let's start with the sliding and dividing process. Okay, so I'm going to slide my A to my C. So 1 times negative 12 is negative 12. Okay, I slide by A, and don't forget, you must divide by A. So I slide by 1, which means I need to divide by 1 when I get done. So we find two numbers that multiply to be AC and will add to be B, which B is 4. Okay, so I need two numbers that will multiply to be negative 12, which remember, if you're going to get a negative, what times what gives you a negative number? Fabulous, you guys, fabulous. I need one negative and one positive. A negative times a positive is a negative. Okay, so let's keep that in mind. So I'm going to brainstorm some numbers that will multiply to be 12. So let's see here. But you guys know I'm horrible at doing this. So let's see. I'm going to start with 1 and 12. Let's see what happens. Okay, so if I do negative 1 plus 12, well, that's 11, so no, that's not going to work. If I do negative 12 plus 1, well, that's negative 11, so nope, I'm already off to a bad start. Let's think of something else. What else multiplies to be 12? Well, I know 3 and 4 does. So let's see, negative 3 plus 4, well, that's 1. I'm trying to get 4, so that doesn't work. And 3 minus 4 is negative 1. Shucks, does not work. So what's something else I can use, you guys? I mean, you guys are always so much better at this than me. So what's something else that will work? What do you think? Oh, yep. Yep, I see it now. I think it's going to be 6 and 2. What do you guys think? So let's see here. If I do negative 6 plus 2, that's negative 4. But 6 minus 2, well, that's positive 4. Holy hot dog, we have found it. Yes. Okay, so I know my 2 must be negative and my 6 must be positive. Because negative 2 times 6 is negative 12 and negative 2 plus 6 is 4. Okay, so now that I found my numbers, I'm going to bring them all down. So minus 2 and plus 6. Let me reduce these down. So negative 2 over 1 will reduce down to x minus 2. And 6 over 1 will reduce down to positive 6. Now, don't forget at the very end, we must bring down our GCF. Very important. Don't forget about your bestie. The GCF always gets forgotten, you guys. And I just hate that it always gets forgotten. So let's try not to forget about that. Okay, so now I have 3 factors. Remember, you guys, factors are things that multiply together. They are numbers that multiply to equal another number. So I have these 2 are secretly separated by multiplication, and these 2 parentheses are. So I have 3 factors right now. Okay, so if I have something times something equals 0, well, one of them has to be 0 if you're going to multiply to be 0. Okay, so remember, you set every single factor equal to 0, but don't forget you only set factors that have x's in them equal to 0. Like this negative 1, if I set negative 1 equal to 0, that doesn't make any sense. Okay, so I'm not going to set negative 1 equal to 0, but I am going to set x minus 2 equal to 0 and x plus 6 equals 0. Okay, so then to find my zeros, my roots, my zeros, my solutions, or my x-intercepts, which the x-intercept one is kind of what we're doing right now because we're talking about a graph, I need to solve for x. Which, if we think about up to here when we were solving these problems, I kind of gave you a shortcut for how you could jump from your x values into factored form. So guess what? The reverse is true. When you're in your factored form, the way you get your x's, you can simply just flip the signs. But be careful, you can only do this when the coefficient or the number in front of your x is a 1. Like if this was like a 2x plus 2, I couldn't flip the signs. It's only when 1 is in front. So just be careful. Okay, so I'm going to use my fancy shortcut to flip my sign. So the opposite of negative 2 is positive 2. So x could be 2, or the opposite of positive 6 is negative 6. It could also be negative 6. So there we go. These are technically our answers. But we are not done because the problem is not asking us just to solve for x. It wants to know what is the width of each arch at the floor. I want to know how far each arch is apart, or each endpoint of the arch is far apart at the floor. Sorry, I don't think that made any sense. I want to know the distance from each point of the arch at the floor. That's what I meant to say. But anyway, so to figure out the width of the arch, these values, you guys, are your x-intercepts. They go on the x-axis, which I have right here another coordinate grid so we can actually kind of graph it and see how far apart our two x's are. Because the two x values, these are two x values. The distance in between our two x values will tell me the width of the arch at the floor. Okay, so we have one x value at a positive 2. So I'm just going to draw on here like this. Oh. So one of my zeros is at a positive 2. So this is one of my x's. The other one is at, that says negative 6. I know it's hard to see. So 1, 2, 3, 4, 5, 6. So I don't really know how high up the arch goes, but that doesn't really matter because all we want to know is how far apart is the arch at the floor. So I want to know the width. I want to know the distance from here all the way to here. Okay, so what do you guys think I could do to find the distance between this x and this x? Exactly, you guys. You could just count. Like I could just say 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are 8 tick marks in between each of these x values. So the width of the arch at the floor is 8, and they also told me that the x and f of x are in feet. Okay, so whenever you're doing a word problem or something that actually occurs in the real world, not the math world, it's always good to include your units. So I know that the width of the arch is going to be 8 feet. So I don't really have much room to write my answer, so I'm going to write it right here. So the width of the arch, that is going to be 8 feet. So there you go, you guys. We solved for x, and we actually were able to apply it to a problem to help us find the width of the arch. Wasn't that awesome? I know! So example 8 is very similar. We're just going to be talking about a rocket that gets launched out, and we're going to see when that rocket will hit the ground. So let's get started on example 8.